Welcome to Study Loop.
This is chapter 21, problem number 44. A coil has the resistance of 2.25 ohms. The inductance equals 112 millihenries. If the current is 3 amps and is increasing at a rate of, delta I over delta t, let's put for the rate, is 3.8 amps per second, what is the potential difference across the coil? So potential difference across the coil. So I am going to ask you to imagine the coil as just a separate resistor, right? And an inductor, RL. So let's get this point, label this point as A, let's label this point as B, and assume that the current is going towards right and it's increasing, the rate, right, is given to us here. Now, if we want to know the potential difference across the coil, then we want to know VAB here, right? So if we want to know potential across, we know that across a resistor, the potential is going to drop by I times R, right? So the overall, what the potential between these 2 points are going to be equal to is the potential across the resistor plus the potential across the inductor. So the potential across the resistor is, from Ohm's law, is I times R, and the potential across an inductor is L di over dt, right? So all we need to do is to plug in for I, R, L, and the rate here. So I is 3 amps, R is 2.25 ohms, plus the inductance is 112 millihenries. So let's convert that to henries. And then we have the rate, 3.8 amps per second. So then from here, the potential difference across the coil is going to be equal to 7.18 volts.